what is the location to do that. The calculations that we have done here with group number, inode in table, and so on and so forth, and we also have the inode block here. These are all important. So we have to figure out how to utilize all this information in order to get to the answer. Now, first of all, we have to remember or understand how the inode table works. The inode table it's not always that a extension to file system has one single inode table. It is separated into block groups. Each block group has its own inode table. So the first thing we have to do is to find out which block group we are dealing with, and that's calculated by the group number. The group number tells us which block group we are dealing with. So what we need to do at this point is to utilize, okay, let me see if I can split the screen. Let's see, save all, view full screen. Nope, doesn't look like we can do that. So what I need to do is to go back to the structure here. The structure here has a block group DT, which is the block group descriptor table. Now that is important because if we go back to the, oops, not this one, the documentation here, the block group descriptor table, okay, so let's search for block group descriptor table, and we go back here. The block group descriptor table has all these entries here, each one corresponding to one block group, and in other words, you can look at this as one structure, and the block group descriptor table is an array of these block group descriptor items. And so if we switch back to the notes here, it's called block group DT. So let's switch all the way to here, to the call. Okay. Alright, so the first thing we need to do is to find out where is the starting point of that particular inode table. But since we have the entire block group descriptor table already read, and you can verify that by tracing when this particular function is called, because it is always called after we have read the entire block group descriptor table. So the first thing we have to do is to find out where is the beginning of that inode table, and that can be done by, okay, if we switch back to this one here, the entire table has 32 bytes, so we have to multiply 32 by the block group number first in order to get to the correct entry. Okay, so what we need to do is to say okay, so we use the same trick here. We have to cast everything into a 32-bit pointer, a 32-bit integer pointer, and then dereference that so it becomes a 32-bit number, because what we are after is we are after this BG inode table, and the expression is p info points to block group descriptor table, which is an array that we have allocated when we call the function to read in the entire block group descriptor table. But we don't want to start from the beginning. We want to start from 32 times our group number here. This will get us to the beginning of the block group descriptor item that we want to access. But after that, we have to access the inode table entry, and that has an offset of 8. So then we specify 8 here, Okay, so this part will read okay, let me highlight the portion here. The highlighted portion here will specify um, the offset to the inode table that we are dealing with, but not the inode that we want to read. So what we need now is to rely on inode in table, which computes the index into the inode that we need, but from the perspective of the inode table that is specific to the block group of group num. So this number is good as a starting point, but it is not entirely what we want. So we'll just put parentheses around this and add some more entries to it. Okay, so now we have to find out how big an inode is, and that's the other part. The size of one inode is already known to be this size here, so that means we can utilize that information again, and we just add that number, inode size fs info p info, and we want to multiply that by inode in table. There we go. Okay, let me just put parentheses around things so it's easier to read, and also change the indentation and use separate lines so that things become more clear. There we go. Alright, so now I can explain this entire thing again. The first parameter to seek and read is p-info, which is the structure that we're passing around that contains all the information that we need. The second item specifies the displacement from the beginning of the entire file system to the inode that we want to access. To figure that out, we have to first refer to the block group descriptor table of the entire file system, and we add 32 times group num plus 8 to the whole thing, because group num specifies the block group that we are dealing with, and 32 is the size of each block group descriptor. In other words, this part here specifies the beginning of the block group descriptor item that we need to access, but we don't need the entire item. We only need to find out where the inode table begins, and that's why we have to do a plus 8, because offset 8 is where we store the inode table address of the inode that we need to access. But that will only give us the beginning of the entire inode table, but not the inode entry that we want to access. So that's why we have the last item here. The last item here is basically calculating based on the index of inode in table, which is the index of our inode in that particular block group, and we have to multiply that by the size of each inode so that we can index